And now let's look at how we find resultant vectors. What that means is you have two vectors, and when you add, you get a resultant vector. Now here's how we add. You take vector A and vector B, you're going to add them tip to tail. So this one's tip is going to connect to this one's tail. So basically it means this. You're heading one direction and you decide to turn a different direction. That's how vectors work. It represents addition of two vectors is like if you're going one way and then you turn and you head another way. You have a speed and a direction, and then you have a new speed and direction. Or how it could also work is in the terms of like airplanes, is a plane might be flying along this path at this direction, but the wind is pushing it this way, which would affect the plane because the plane is not grounded. Thus, the resultant is from the original one's tail to the new one's tip. So you just follow the path. This is where we started. This is where we end when we add them together. Now remember, with addition, it doesn't matter which one. We could have started with this graph and then added the A onto it, and you'd still get the same green line. I know it doesn't look like it here, but let me show you. Here, it says find A plus B plus C. Now, we could just simply add these and say, okay, this one's A plus B, and now this is C, and we get this value here. Now, when we add them together, the actual answer would be representative by this dotted line here. Going from the start to the finish. We would call this one here A plus B plus C. Now let me show you what I have here. If I took the same vectors, I have them added like this, but if I went a different order, let's say I went C, if I started with C, and then I added A to that, and then I added B. Look what happens. You still get the same resultant vector. A plus B plus C is the same thing as C plus A plus B. Well, what about if I went, let's say, B plus C plus A? So we started with B. So we go B plus C. Move the A out of there. Let's say, does it give me the same vector? Yes, it does. It's just I didn't line that up right. Let me get that one better connected. Tip to tail, tip to tail. And now you can see that, yes, it does work. So these always do add up. That would be the point there, is it doesn't matter which order but as long as you go tip to tail, you should always get the same resultant vector. So now here it says on example 3, find the resultant of two vectors. So while hiking in the woods, Shelley walks 2 kilometers north, 30 degrees west from her camp, and then walks 2 kilometers directly east. How far and at what quadrant bearing is Shelley from her camp? All right, so a quadrant bearing means this formula here. So from like north 30 degrees west or something like that. So let's start and see what happens. Shelley walks 2 kilometers north 30 degrees west. So first, an X and Y coordinate plane. We have north here, east, south, and west. And the original vector she takes off on is north 30 degrees west. So I go north and then 30 to the west. And it goes, we got travel for 2 kilometers. So I'm going to say this right here is 30 degrees from the north to the west, and that's 2 kilometers long. Now it says she walks 2 kilometers directly east. So what that would mean is starting from that same point, we now turn from here and go tip to tail and go 2 kilometers this way. And so I'm going to draw it like this. It's about the same length there. That's 2 kilometers. Now, obviously, my drawings are never to scale, but this is the best I can come up with. So it says, how far and what quadrant bearing is Shelley for a camp? Well, the camp is where we started. So the resultant would always be from where you started to where you finished. She took off on this path and she turned this way. We want to find this value. So here's the math behind it. We add these two vectors together. And so you can add them by, what we're going to change is we're going to get these as x's and y's. So right now what we have, the way you'd represent this, is we have a hypotenuse of 2 kilometers and an angle here. If we went from the x-axis, that would be 90 plus 30. This would be 90 plus 30, which is 120 degrees. Here's the way we could write this as a vector quantity. You can always say h comma angle, or you can put it as x and y's. Now this next one I'm going to turn as in x's and y's. This does not go up or down, rather it goes straight to the right. So I go 2 to the right, but I do not go up or down. So what I have done is I wrote this one as a magnitude and a direction. This is a magnitude, this is a direction. And I'm adding it to a different format. I'm adding it to an x and a y. Now, if I add those together, the calculator will do the rest for me to come up with this part on the math. So let's go over to our calculator. And I'm going to clear this off. And so we add them together. Now, this symbol, let me go back over here, is not in the calculator. So instead, we're going to use these brackets. So the way I'm going to type it in is I'm going to come over here and say, with brackets, controlled parenthesis, which gives me these brackets, 2 for my hypotenuse, comma, the angle button is there with it. When you click on the book, you'll see it right there. So 2 angle, and my direction was 120 degrees from the positive x-axis. Now we're going to add that to the vector 2, comma, 0, because I went right 2 units, but not up or down. When I add these together, the calculator always gives me the value in x and y's. So this right here, let me just take a picture of this, so if we need it, would represent our value. So it says, and I'm just going to kind of round it here, we'd have a value of 1, comma, 1.71. Now I can also change that and put it into h, comma, angle. Let me show you how we do that, because it says how far and what quadrant bearing. So I need this as an angle. So the way you can do this is if you press menu, we'll go down here to vectors, matrix and vectors, and at the very bottom you will see vectors, part C. When I click on that, I have these options. And let me zoom this out so you can see a little better. Here, convert to polar is what we're going to choose. Now polar is something you're going to learn about in chapter 9, but until we get there, I'll just tell you this. It'll convert it to h and angle. So when I press enter, it takes these x value and y value, and it makes it an h and an angle. So now let me take a picture of this, and I'm going to paste it over here. So now I know that she traveled a total distance of 2 kilometers at an angle of 60 degrees. Now that's what that tells me. So the answer here, how far did Shelley walk? She is 2 miles away. She's 2 kilometers away from camp. 2 km from camp. And not only that, 60 degrees, this would be from the x-axis. So this angle right here is what we have just determined, is that this angle right here is 60 degrees. So you could rewrite that. If that is 60 degrees right there, that's 60 degrees from the east going to the north. But normally the way we would write it is from the north going towards the east. So you would say this 60 minus 90, which would be 30 degrees, is the angle from here to here. This right here would be 30 degrees if it's 60 going this way. So we'd say a north 30 degrees east. This would be the answer. And again, if you wanted to, you could say at east 60 degrees north. That's the way the calculator gave it to me there. So either one would be acceptable, but that's how you do that. All right, you try this problem and see what you come up with. And you know what, by the way, I just kind of skipped over this. If you don't have a calculator like this, how do you get out of this form? Well, this is an h and the angle. Now, how would you change it to an x value so that you could add them with common terms? Well, what you do is you would use psi y and cos x. Remember that cosine is the same thing as x over h. So if you wanted to find your x value and you're given an h and an angle, you could just say that x is going to equal h times cos theta. And furthermore, we can end up getting that if sine is y over h, then if you needed y by itself, you could say that y is h sine theta. So that's basically what the calculator does there, is it changes this. It says 2 times cosine of 120. That's how it got this first value. And then 2 times sine of 120 is how it'd get the y value for this purple. That's the math that's included there.